In this video, we're going to focus on finding the integral of sin x cosine x. Now, there's three ways in which we can get the answer. The first technique involves u-substitution, and we're going to replace u with sin x. Du, the derivative of sine, is going to be cosine x dx. And so let's substitute sine with the u variable, and let's replace cosine x dx with du. So this becomes the integral of u du. Using the power rule, this is going to be u to the second power divided by 2 plus some constant c. And then now we need to replace u with sin x. So the answer is going to be 1/2 sine squared x plus c. So this is just one of the three ways in which we can represent the answer. Now here's the second way. So let's start back with the original problem, but instead of making u equal to sine, let's make u equal to cosine x. Du is going to be the derivative of cosine, which is negative sine x dx. Now in this example, I'm going to solve for dx. It's du divided by sine. So let's replace cosine with u, and let's replace dx with du divided by negative sine x. So we're going to have the integral of sine x times the u variable times du over negative sine. So we could cancel sine, and so we have negative integral u to the first du, which is going to be u squared over 2 plus c, and this time u is cosine. So this is going to be negative 1/2 cosine squared plus c. And so this is the second way to represent the answer. Now let's focus on the third method of getting this answer. It has to do with the double angle formula of sine 2x. Now sine 2x is equal to 2 sine x cosine x. So if we multiply both sides by 1/2, we're going to have 1/2 sine 2x on the left side, and on the right side, 2 times 1/2 is 1. So it's just going to be sine x cosine x on the right side. So therefore, what we're going to do is replace sine x cosine x with this expression. So now we have the integral of 1/2 sine 2x dx. Now I'm going to move the constant to the front. Now what is the antiderivative of sine 2x? The antiderivative of sine is negative cosine. The angle will stay the same, 2x, and then we need to divide it by the derivative of the angle, which is 2, and then plus c. So the answer that we have is negative 1/4 cosine 2x plus c. So the three answers that we got for the integral of sine x cosine x was this one that we just got, and then the first one was 1/2 sine squared x plus c, and the second one was negative 1/2 cosine squared plus c. Now the reason why we have these three answers is because there's multiple forms of the double angle formula for cosine 2x. I'm going to focus on two of the three forms. Cosine 2x is equal to 1 minus 2 sine squared x, and it's also equal to 2 cosine squared x minus 1. The third form is cosine squared minus sine squared. So starting with this expression, let's replace cosine 2x with this expression. So it was negative 1/4, and then instead of writing cosine 2x, I'm going to insert 1 minus 2 sine squared. And let's not forget about the constant plus c. So this is going to be negative 1/4, and then if we multiply negative 1/4 by negative 2 sine squared, it's going to be positive 1/2 sine squared plus c. Now, when you add negative 1/4 plus some unknown constant, combined, you could just write it as a single constant. So we can replace negative 1/4 plus c with just c. So that would be just a generic constant. And you can see that you get the same expression. Now let's replace cosine 2x with cosine squared x times 2 minus 1. So instead of writing negative 1/4 cosine 2x, let's replace the cosine 2x with this. And then we have a plus c on the outside. So negative 1/4 times 2, that's going to be negative 1/2 cosine squared x. And then negative 1/4 times negative 1, that's positive 1/4. And then plus the constant c. So 1/4 plus a constant is equal to another constant, which we can just replace with some generic constant, just like we did before. And that will give us the same expression. So as you can see, you can write the integral of sine x cosine x in any one of these three forms, because you can convert one form into another using the double angle formulas for cosine.